Okay, so if kx squared minus 4x plus k minus 3 equals 0 has real roots, show that k squared minus 3k minus 4 is less than or equal to 0. So I've rewritten this quadratic down here, okay, and just to make it clear, I've just put a bracket around there, so then you know then what your a, b and c clearly identified are going to be. So let's write them out first. So your a is the value in front of the x squared, which is k. The b is the value in front of the x, which is minus 4. And the c then is this constant at the end, which is that bracket k minus 3. Okay. Now, it's interesting here, it just says real roots. Okay. It doesn't say two real and distinct roots. It just says real roots. So in that situation, we've got two possibilities. Okay. It could either be that b squared minus 4ac is greater than 0, okay, which means then we would have two real and distinct roots, okay, or it could mean b squared minus 4ac is equal to 0, which means we have equal, okay, real roots. Now either of those cases could apply here, okay, because it just says it has real roots, okay. It's not clear, isn't it? It's not saying it could have two distinct roots. Okay, they could be equal. Both of those possibilities here could apply. So when you combine these two, it could be greater than or equal to. We end up having b squared minus 4ac is greater than or equal to 0. Okay, so it could either be greater than or equal to 0. So we write it like that. Now, don't get confused but a minute, because you're looking at this here and you'll notice the inequalities going the other way. Don't worry about that for a minute. Just focus on this fact here. And this is true in the case that we've got real roots. Okay, it's either the case of two real and distinct roots, so you have two different roots, or we could have equal roots. Either way, they both situations produce real roots. So it's a combination of these two rules here that's being applied. And we're going to say that given we have real roots, given real roots exist, then we say b squared minus 4ac, okay, is greater than or equal to 0. Again, don't get put off by the fact that that's going the other way. That'll be sorted in a minute now. So substitute in minus 4 for b. So remember, we've got to square it to put a bracket around it. Minus 4. A, which is k, so times k, and then c, which is k minus 3, so times k minus 3 is greater than or equal to 0. So you square this, negative squared becomes a positive, so 16. Multiply the bracket, so minus 4 times k is minus 4k squared, and minus 4k times minus 3 is plus 12k, yeah, because a minus times a minus is a plus. And that's greater than or equal to 0. So just like we had in the previous example, let's just rearrange this. So we have the minus in 4k squared at the front, plus 12k plus 16 is greater than or equal to 0. And then you've got this issue of nu, with the quadratic. Okay, we don't want to have a minus in front. So what we're going to do then is, we're going to change all the signs by dividing by minus 1. Okay, so divide that by minus 1, you get 4k squared. Divide this by minus 1, you get minus 12k and then minus 16. So all the signs change. But when you divide by minus 1, the direction of the inequality has to change as well. Whenever you divide by minus in inequalities, the inequality direction changes. So you've got this. Look at what we want. It's very close. And I hope you can see then there's a factor of 4. So if we divide by 4, we'll get k squared, because 4k squared divided by 4 is that. Divide that by 4, you get minus 3k. And divide that by 4, you get 16 divided by 4 is 4. So we get exactly what they want. Then it goes on and it says, hence find the values of k such that kx squared minus 4x plus k minus 3 equals 0 has real roots. So basically they want us to solve it now. They want us to actually work out what values of k produce these real roots. Okay, so if you think about it, this inequality is the result of having real roots. So if we can solve this inequality for k, then we've found the values that we need. Okay, so remember now, when it comes to solving inequalities, what you do to start with is you focus on where it's equal to 0. Okay, So we look at the critical points. In other words, k squared minus 3k minus 4 is equal to 0. Okay, you then have k in both brackets, two numbers that multiply to give minus 4 and add up to give minus 3. Well, we saw it last time, that becomes a minus 4 and that becomes a plus 1. Okay, equals to 0. So then when you've got two brackets equals to 0 times together, either k plus 1 is equal to 0 or k minus 4 is going to be equal to 0. So it means k is equal to minus 1 or k is equal to 4. So remember now, we've solved this now where this quadratic is equal to 0. Okay, so we can draw a quadratic, smiley face, a parabola, and it goes through the, in this case it'll be the k-axis, right? It won't be the x-axis, it'll be the k-axis because everything's in terms of k. But it goes through the k-axis at minus 1 and 4. Okay, so we can draw our quadratic. Okay, now we're interested in solving the inequality then. So we go back to the inequality. So remember now, we're interested in when it's less than 0. So in other words, when the curve is negative. So the curve is negative for these k values here. Yeah? These k values here, that's when the curve is negative. So in other words, k has got to be less than or equal to 4. It's got to be less than or equal to 4, but it's also got to be greater than or equal to minus 1. So we write that first and then just copy the inequality here. So we say that k is between minus 1 and 4.